I've just designed a circuit board, which is going to be basically for a cluster of LEDs. Of course, it's going to be a decorative circuit board. That's the sort of stuff I do. And normally when I've designed the circuit board and made the transparency, I would use my favourite printed circuit board material, which is this lovely white laminate with the light sensitive layer on it. Unfortunately, the company that makes this, I usually get this from Mega Electronics, and the company that makes the material is discontinuing it as far as I know, because the machinery they use to put the multiple layers together is in need of replacement, and they don't sell enough to actually justify it. Because what this is a layer of fiberglass on either side of resin bonded paper in the middle. It's just a lovely material to work with. It's a very good prototyping material. So since that material is now being discontinued, I thought it's time to explore the other options. Another option, the most popular option on eBay at the moment, is getting standard copper clad board and putting your own light sensitive layer on it, the thin film layer. And I have to say my first attempts at this were a bit abysmal. But let's have another go and see how it looks. Now this is still wet. I want to say for a start, this circuit board, I've cleaned it, and to clean it I used a standard sponged back scrubby pad, because the scrubby side does a fantastic job of cleaning copper in a non-scratching way. It puts very fine surface on it. So I've got a choice of the film. If you go on eBay, you'll find the film is available, this light sensitive film, in flat sheets like this, whereby it comes pre-cut into suitably sized sheets. Or the other option, and I get mixed thoughts about the other option, is that it can come in a roll. Hold on, where's the little roll I've got? Comes, and it gets delivered like this, a little plastics of bit of black film that they've basically taken the roll of this stuff and they've wrapped the black round it, and then they've stuffed it in the end and then squished it flat. And it's the squishing it flat that's a problem, because I've got some that's all covered in creases, and the creases are, you can't get rid of them. It's very annoying. Now, theoretically with this stuff, let's see, let's put it on like that. It's not going to cover completely, or do I overlap? I'll overlap, I think. Oh yeah, I'm going to overlap. So I'm going to cut a piece of this off and put the other bit out of light's way. I can't really work in the light too long with this because it is light sensitive, most notably ultraviolet sensitive. So what I need now is a bit of tape. And what you've got here is you've got a layer of light sensitive gel sandwiched between two bits of film. Now you'll notice this is still wet. It's wet for a reason, because I tried initially laying this on and putting it through a laminator, and it was just an absolutely it was a dire result. So to start off, you put a bit of standard sellotape on both sides like this, and then you peel them apart, and at the corner one side of it is going to peel a clear layer off. It's kind of, you know, whichever one gives first. So that's me taking a protective layer off. And what I'm going to do now, and this is the best result that I've had, I'm going to spray the circuit board with water and put it on as though I'm putting on vinyl film onto, well, a car, you know, signage type stuff. So I'm going to lay this on very carefully. And then I'm going to get a standard squeegee for, the felt edge squeegee for vinyl film, and I'm just going to squish any bubbles out. And you have to be very careful, because if this stuff is stretched, and it's got little crease marks here which show it is kind of stretched, then it causes problems. It causes little creases that will end up being very hard to remove. That's why maybe the flat sheets are better. And you also want to go fairly easy with the squeegeeing, because you don't want it to be you don't want to stretch it, because then it will sort of coil back up. So now I've done this, I'm going to put another bit of paper on top of this, and I'm going to put it through a laminator. I'm also going to cut this bit of tape off before, no, it's too late, it's just stuck. Okay, back in a moment. So that's been through the laminator twice, so let's see how it's fared. It looks a bit streaky. I think there's excess moisture, but then having said that, I don't know if it's going to affect it adversely. It feels smooth enough. So now, this is where I made a mistake last time. when I exposed it last time, I peeled the other layer off. I think I'm going to leave the other layer on this until I've exposed it, because I found that the transparency actually physically stuck to the gel. So I'm not going to fall for it this time. I'm going to cut this off initially, flush with the edge of the circuit board material. Then I'm going to put the transparency on it. I'm going to cut it to size. Then I'm going to expose it to ultraviolet light with my transparency. And we'll see what happens. We'll see how it takes it. Okie dokie. So this is my coated laminate. Yeah, it doesn't look as nice as the stuff you get out the suppliers, but that's maybe just because of the way I've done it there. Anyway, next step is to expose it with my transparency, which in this case it's the negative working photoresist. So I'm going to use my circuit board on it like this, and I'm going to expose it for about 2 minutes, and we'll see how it comes out. I've placed it in my trusty tubes in lid ultraviolet exposure unit from Mega Electronics, and I'm going to clip that lid down and give it 90 seconds. So this will thoroughly expose the circuit board, and then we'll see how it comes out. After the 90-second exposure, there's a vivid difference. The material, the gel here, has cross-linked wherever it was exposed to ultraviolet, and that's effectively hardened it. And where it's not, it's going to be soluble, and it gets exposed in a solution, a 1% solution of sodium carbonate, not bicarbonate of soda. It has to be sodium carbonate or potassium carbonate, I think is the other one. In my case, I just use standard washing soda crystals, which are sodium carbonate. I've never tried this before. We'll find out if it works. I normally use, well, the earlier experiments I've done this, I've used this proper commercial potassium carbonate one. So I'm going to put a bit of tape in this and try and take the other layer of film off. Here it comes. That's good. That's a good result. I'm going to drop it in, and this is where you have to sort of let it develop a bit, and then you have to rub it. Because the gel sort of softens, but you have to sort of wash it away and move it away with your fingers. So this could take some time. It depends on the exposure level. It depends on the concentration. Actually, it's the complete opposite for the exposure level. Traditionally, with the positive working photoresist, it would cure it wherever the ultraviolet. Let's see, how does it, I'm just trying to remember. Yes, it actually weakened it where the ultraviolet hit it. With this stuff, it hardens it, so it's completely different. It's something I'm just not used to working with, this stuff, so I'm not sure how long this is going to take. I'm not even sure if the developer is going to work, so I shall pause for a while and then tell you the results afterwards. Well, that seems to have come out absolutely brilliantly. Unusually with this system, you use another sponge to actually sponge backwards and forwards. And traditionally with the original development system, you'd always worry about taking the coating off, but this is really tough. You can actually feel it like a raised layer. So the next stage is etching, and it's another change. It's the first time I've ever used sodium persulfate. Is that right? Sodium persulfate, I think it is. Etchant, and it's 200 millilitres of water and 50 grams of sodium persulfate, which I've just never tried before. So I'm using the Sino GS style system here of the lay flat tubing with the bag clips. The bag clips I'm using are just eBay bag clips. So let's pop this on. Sino GS is an etching system. I think it was designed primarily for the educational industry. And it's very good. It keeps everything clean and in the bag. Unfortunately, it's a wee bit harder to get these days, particularly depending where you are in the world. So is this going to etch? With ferric chloride, I'd have expected that to instantly change colour and look all tarnished. So I'm not sure what's going to happen here. I'm not seeing anything really obvious happening. I really expected something more vivid than that, but we'll give it time and we'll see what happens. Goodbye sodium persulfate, and hello my old friend ferric chloride, because it turns out that sodium persulfate is an extremely slow etchant and from the point you've mixed it, that's it. It's going to start expiring right there and then, and literally weeks later it's dead. So ferric chloride, on the other hand, you can use it. It gets slower and slower over time, but you could store this for 10 years and come back to it and it would still be etching circuit boards. So this is a much better option, and it's just having an instantaneous effect. As soon as you put the circuit board in, you see it etching deeply into the surface. Let's see how it's doing. In fact, if I tilt it up to that end, grab the circuit board. Ah yes, it's etching in nicely. So I'll be back in a moment. I'll just keep patting this and we'll see how it's progressing. So that's the etching completed, and I've also cropped it down in size and put it in a Ziploc bag with some Poundland acetone. You can get the acetone from just general nail nail care suppliers or as a general solvent. So I'm using that to just rinse off the last of the resist, and the circuit board is just about ready. I'm going to rinse this with water now and then start drilling it and putting components on. So this circuit board is going to have 16 LEDs, and each LED is going to have its own resistor because it's going to be running off a USB power supply. It's just a decorative cluster of LEDs. Now, when I drilled these, it had that slight niggle that I've had in the past, whereby when I like it, the circular pad, I like it to have a small indent, a hole through the copper to represent where the drill's going, and it didn't really come out. I wonder if I should leave it to develop for longer next time. I'm not sure. It'll take some experimentation, or just make sure that I pay extra attention to rubbing those areas while it is developing, because it's just that tiny little recess that just helps the drilling, because when you actually drill the circuit boards, the indentation in the copper is enough to actually just help align the drill bit. For many of these, I had to just kind of aim for the middle, and that doesn't always go so well, because if you're drilling by hand, the drill can skip a little bit. So now I'm just finishing soldering the resistors, and I have to say, because it's a circle of resistors, the drilling of it is the drilling wasn't too bad, but the soldering the components in, you don't even need to tape them in or put anything to hold them in. They just seem to actually balance off and hold themselves in nicely. So yeah, that's looking pretty good so far. It looks quite neat and symmetrical, doesn't it? So next comes the LED stalks. Once again with this arrangement, I'm using my favourite little Molex connectors, well, Molex knockoff type connectors, with solid core wire, lengths about, what length is this? About, let's get the measuring tape in. It's just a random length I chose. So the length of the wire itself is about 5.5 inches, which equates to about 140 millimeters. And I've put the crimp onto each end, and I'm just snapping it into the holder. And then I'm putting these, well, first of all, I'm pulling the wires taut and then cropping them to the equal length and stripping them just about 5 millimeters, just under 1/4 of an inch. And then I'm putting the positive into the middle here. I'll try and no, I won't try doing both at once. That is tempting fate. They'll just start popping out. Solder. This is kind of like the USB powered sprig of light thing I did before. Except instead of putting a resistor in line with each lead, in this instance, because I've got a circuit board here, quite a neat circuit board I have to say, I quite like it. It means that the resistors are all on the circuit board instead. It just makes it a bit easier to make. This is going to be quite a nice ornament. Not that I actually need any more illuminated ornaments in this house. So that's the last of the positives soldered. Now I'll put each negative into its matching position. It doesn't really matter if it goes into its matching position, since it is just a resistor in series with the negative lead of the LED and the negative rail of the power supply. suddenly realised I could have got a wee bit more organised and got some other stuff, but I didn't. So I may have to pause this video and do a little jump cut again to get some of the other bits. So in goes the last negative connection with the LED. And because I'm going to be connecting to this with a USB lead, I did toy with the idea of putting a small USB connector on the circuit board. But then I thought it might actually be easier. Now I've got these soldered, and I'll just twist this around. I thought it might be easier and more robust and easier to solder because I'd use a micro USB and it's kind of footery to solder. I thought maybe I'll just design it to use a standard USB lead. And I've added 2 holes under here for a cable tie and then 2 large pads for the positive and the negative. So I'm just going to crop these leads now. And then after I've done that, I'm going to get the cable, which I should have looked out, and a cable tie. And then I'll be back and we'll stick that in, and then I shall load it up with some LEDs and we'll see how it looks. The holes here, I've made these 4mm to take a standard printed circuit board standoff pillar. Ultimately, in the final design, yeah, I'll probably stick with 4mm. I could use 3mm for standard hardware, so it could just be use the standard sort of threaded spacers, but having said that, the standoff should work fine. Right, I'm just going to go and grab a lead. I'll be back in a moment. That just leaves the addition of the USB lead and a cable tie to hold it in place. So let's use this typical generic dollar store Poundlandy type thing. This is a lead intended for iPhones. I just chose it because it was a nice colour and it's just a generic cheap lead. Plug in the end and a good length of cable that can be used for many applications. I suppose, including charging an iPhone. So I'm going to strip that off. Nibble round here, crack it back, see if I can strip that off. Get off. Try not to nibble right through the wires. This was quite a nice project. It just felt relaxed. So we've got the red and the black here, we've got the white and the green. We don't need the white and the green, I'll just crop them flush. In fact, I'll cut one right down hard and just one a tiny bit longer. And I shall strip the red and the black. This is when I should actually check the polarity, because you just never know what you're going to get. The Poundland stuff has been pretty good that way. The red has tended to be positive and the black has tended to be negative. But you know what? Let's not just assume things because, well, as you know, things can go horribly wrong. So we'll set this to volts. I'll bring in a USB power supply, plug this into it. This is one of the sort of dumb power supplies that it puts out 5 volts all the time, which is what we want. I shall put the red on the red, or the pink in this case, and the black and the grey, and it's displaying 5 volts with no minus symbol, so that is the correct polarity. Excellent. So I shall tin those leads. This feels like copper. I have to say the insulation is shooting away from the soldering iron, as happens with these. And I'm just going to solder the positive onto the positive pad here. And the negative onto the negative pad down there. I'll solder them on sideways just because it kind of suits it. In hindsight, the USB connector would be quite nice, just using a standard micro USB connector. And will my idea of using a cable tie work? Let's see how this goes. A bright yellow cable tie, perhaps not the best choice. Feed that back down through there. Well, that's kind of working. Kind of strain relief in a way. Is that going to work? Oh, I rather think it is. Yep, that looks pretty good. integrated strain relief. I've got these spacers that I can just push in. I'm just skittering LEDs all over the place here. So I'll put these in all around as little feet. That won't make it terribly stable. It really needs to be screwed to something to make it stable. And then how about the shaping of the branches? Theoretically, I could just plug this in right now to the USB power supply. Now, should I just spray them out from there, or should I twist them? How are they going to twist? Oh, actually, they're going to twist quite well. That is pretty good. So let's go for the little tree look. Oh, I'm liking that. The fact I spaced them out, and also I kept these, the red and the black, well away from each other so that if the insulation shrinks up when you're soldering it, it's not likely to short out. So that just leaves LEDs to put in. So I shall plug this in. Plug the first random LED in, and it's quite easy to determine where they're going because it's got the black and the red. You could have used any colour really, green, brown, anything, just so long as you remember which is you're going to use as positive and negative. I've used brown and green in the past for my original Techno bonsai, if you find it on the website, the LED bonsai tree, and the reason I used that was it was kind of more sort of tree-ish type colours, but still identifiable. The brown was the sort of positive and the green was the negative. So I've got a mixture of cold and warm white LEDs here. So I'm going to just put them in randomly, mainly because I've mixed them all up. The anvil shape in the LED usually denotes the negative. It doesn't always denote the negative, but it's quite often it does. I'll probably end up with clusters of I should have actually deliberately mixed them up because I've gotten quite a lot of white ones next to each other here. In fact, let's shuffle them right now and pop that one out and see if we can find a warm white for that position. You could use any colour really, and any style of LED. The resistors have been chosen based on the LEDs being typically about 3 volts and the 5 volt meaning that 2 volts is dropped. And I've aimed for about 10 milliamps per LED, which means the whole thing with 16 LEDs is going to draw about 160 milliamps, or slightly more if the red LEDs or the yellow LEDs are used, because they have a slightly lower forward voltage, which means that more current would pass through that resistor. Yeah, this is all going together quite nicely. This is looking nice already. It's going to look even better in the dark. And of course, being everything's in sockets, so you can just swap and change LEDs at your will. Or you could also use colour changing LEDs in it. Oh, that's an idea. Oh, that would have been nice. I've suddenly realised that would have been nice. Quite tempted by that now. To make a little colour changing tree. And there should be one socket left. There it is. I have got a large cluster of the... I may swap some of the LEDs around just to, before I... Yeah. Let's pull out that one and swap it for that one. And swap this one to there. Just to get a rough balance. It doesn't really matter that much. Randomness is good. Yeah, that'll do. Oh, why has that just gone out? What if I just shorted? Oh, you know what? I think the battery's just run out in this. Well, after a slight blip there, they went out while I was rearranging the LEDs. It turns out that the Poundland lead has been mal-moulded at this end, so Poundland failed there. I might take a wee look at that afterwards. But the tree itself, it's got a blue lead on it now, and it's looking nice. It's looking very smart indeed. And I have decided I'm going to try it with the colour changing LEDs, so let's take a look at that right now. Oh yes, the colour changing option is definitely the nicest. This looks really attractive, like a little sort of, oh, what was the name of that film? The one that they had all the sort of colour changing plants, and I've forgotten the name of that film now. Avatar. It's very reminiscent of that in a way, sort of electronic foliage. Yeah, that's quite smart. It looks very tree-ish too. That is nice. So let's take a look at this failed Poundland USB lead and see what went wrong there. So good result with the lights, bad result with the USB lead from Poundland. It looks like the cable had been nipped in the tooling that comes down to actually that the plastic is injected into, and it just nipped by sheer chance, the red and the black had just been nipped together and pierced through. So that's a bit annoying. Is that the first lead I've had from them that's been faulty? I think it is. The tree looks good. I like the colour. I wasn't originally intended to do it in colour, but it does look very, very nice. So this has really been just a test of the process of putting the film onto the printed circuit board, the copper laminate material, and then processing it. And I have to say, of the printed circuit board processing materials I've used, that was surprisingly resilient. It was actually very good. It was easy to work with. It had nice wide exposure and development times, and produced good solid etch. That was very good indeed. So yeah, nice result. I might put this circuit board up on the website at some point, because for just free download, so you can make one yourself if you want, because it does look very good. It actually looks very tree-ish.